What is up guys, Christian from Polarith here, and welcome to our next tutorial. Even though I said the next one would be about vehicle controllers, we decided to add this small tutorial in between because there are many questions in the forum and our inbox about essential topics. Today I want to talk about the general concept of behaviors and the power of combining them. Since we only mentioned this in our basic tutorial video, we want to go deeper now. And even though there is a lot of written information in our documentation, we felt that it is more helpful to simply show some examples. For that, let's talk about the most common problem an agent has to face: avoiding obstacles while reaching a destination at the same time. Here we have a large patch of water, a pirate ship that wants to pick up this treasure chest, and a small island blocking the way. The ship is a rigid body, so we can use the aim physics controller. So let's see what happens. Usually we talk about two common ways of avoidance: the active avoidance and the passive avoidance. The difference is simple. As you can see, active avoidance only needs one objective to work. We just have a seek behavior to find the chest and an avoid behavior with a slightly higher magnitude multiplier. This way, the ship is going to prefer the avoidance direction. This is easy to understand, since it is closer to the avoidance behavior of the classical steering approach, though not the same. The passive avoidance is smarter in some sense. When we say passive avoidance, we always talk about the combination of two seek behaviors. It may seem counterintuitive, using seek to avoid something. However, when using two different objectives and a feasible constraint, some algorithm under the hood finds a solution that is equivalent to avoidance. But how does that work? It is crucial to understand that an aim behavior is not a command to the agent, it is just a routine that samples the environment in a unique way and writes values into its specific target objective. The names we gave them are merely the most likely application, but this is totally not carved in stone. What we actually do by adding objectives and writing values to objectives is to create a so-called multi-criteria optimization problem. In the beginning, I described the most common problem: avoiding something while reaching a destination. This is a basic example even we encounter every day in our lives. We have to find compromises in our decisions to optimize multiple objectives, like reaching a target fast, but avoid running into walls. And we as human beings are good at it. Polarith AI makes use of this concept and solves this problem. What you get is a decision which has to be translated into a movement somehow. But this is the responsibility of a controller and thus another topic. Back to our pirate ship. As we can see, this is exactly what happens. Both seek behaviors write similar values but in different objectives. Only the distance mapping leads to the different magnitudes, otherwise they would be the same. Given our constraint, the solver finds a dominating solution. As you can see, this solution is as good as the other one over here. However, there's no solution that is better than both. The result is a beautiful and smooth avoidance trajectory. Since we understood the concept, we can do some more experiments. Let's try to create an avoidance by using 2 seek behaviors, but only one objective. But how can this work? We know that our treasure seek writes the highest value to the receptor that faces the treasure chest most. We also know that we can control how much this affects the adjacent directions with sensitivity offset. If we use our second seek to search for the island, we only get high values into the island's directions. That doesn't help much. But what if we subtract these values from the treasure directions? This is actually a good idea. We just have to decrease the sensitivity offset on the second seek, since we don't want to erase the possible avoidance directions. It is also important to make sure that seek island has a higher order than seek treasure, since subtraction is not commutative. Let's see if it works. Well, not right from scratch. We need to tweak some values here and try again. Looks different, but great. As you can see, all roads lead to Rome. Okay, now let's conclude what we can take away from this video. First, it is essential to understand that behaviors in our system only write values to a target objective. Do not take their names too seriously and think outside the box. Second, use the power of combination. Do not give up if using one specific behavior does not work. Try to combine different behaviors. Think about the importance of order and operations. And the third point that we should mention as well. For very complex scenarios, there is certainly no combination of behaviors that fits all situations perfectly. For example, a car has to behave differently when it tries to enter a roundabout than driving on the autobahn. So always consider using different AI states when things get too complex. That also helps to organize the agents better. As always, I hope that we've provided some helpful information here. Thank you so much for your support and see you in the next one.